What's up everyone, this is Dariusz Kalbaczyk, co-founder of MG Poland, JS Poland, AngularMaster.dev and WorkshopFest.dev. Welcome back to the Angular Master Podcast. Today, together with Manfred Steyer, who is an excellent speaker, trainer, consultant and author, we focus on Angular. We will talk about Angular architecture in 2024. Hi Manfred, how are you today?
Yeah, I'm fine. Thanks for having me.
So for those who don't know you yet, please tell us about yourself and what you do.
Yeah, I'm Manfred Steyer. I'm a trainer and consultant for Angular, and I'm focusing on Angular in the enterprise. We are doing a lot of consulting and we are doing a lot of trainings there, and quite often it's about large-scale Angular applications. I'm also part of the Google Developer Expert team for Angular.
How will Angular architecture best practices evolve in 2024?
Well, I think it's in general about better meeting the sweet spot between too much and too little. Because I think one of the issues in software architecture is we do sometimes over-engineering and sometimes we do under-engineering, and both is really bad. I really know this because I did it before. I did it in the past when I was a junior developer. The first projects were heavily under-engineered. You need to know we were in project business, and there it's about delivering stuff so that you can send out an invoice. So everything was under-engineered. And then we realized that we need more focus on architecture, and suddenly everything was over-engineered because we really tried to implement everything we learned about architecture. And this was when I learned that it's all about finding the right sweet spot between too less and too much. And I think this perfectly fits to the current Angular renaissance, because the Angular renaissance is also about taking out unnecessary weight of Angular. And so we can also find the sweet spots there. One thing that is still important, and that will very likely be important all the times, is finding good modules with good boundaries. You know the saying, good fences make good neighbors. And I think it's the same with modules and their boundaries. And if we talk about the large-scale enterprise applications where several teams are involved, we also need to find a way that those boundaries and modules fits the team structure, because the team structure always influences how the application is structured at the end. So if you can align both, you have for sure a big win. And in this case, domain-driven design, especially strategic design, which is one of the disciplines of domain-driven design, really helps to find such pieces, such modules, they call it bounded contexts, that can live on their own and that don't need to know much about other contexts. So if it is about finding nice boundaries, I would really recommend to have a look into strategic design. Another thing that is still important is to implement those boundaries. For this, we can go with Ngrx. Ngrx is really a beautiful tool set with a lot of nice stuff for Angular applications. Not only Angular, but also other frameworks like Vue and React and Nest.js and so on and so forth. But it for sure provides a lot of value also if you only do Angular. It allows you to enforce your boundaries between your modules. And last year we introduced Sheriff, which also allows us to introduce boundaries between modules, but on a per folder basis. So it's a bit more lightweight with several consequences, good consequences and bad consequences. As always, it's a bit more lightweight. If we go with Ngrx, we have those boundaries on a per library basis. Another thing that is rather new is signals in Angular, a new reactive building block, and the new Ngrx signal store, which is a lightweight store that works without Redux, which in turn also have some consequences. We have SSR and hydration. We have deferred loading. And perhaps we might get something like server components in 2024. At least the Angular team is investigating this trend we already know from React. This is especially nice if we want to go with public-facing applications. For instance, with a web shop where all is about performance, especially the first pagelet. And another thing that influences our architecture indirectly is ESBuild. Since Angular 17, ESBuild is used by default for new applications, for new Angular applications. So if you ng new a new application, you get ESBuild. And the benefit of ESBuild is it's really fast. In former days, the CLI was using Webpack, and it is still supporting Webpack, but ESBuild provides an improvement in terms of build times. We have seen improvements by factor 3 or 4, which is quite a number when it comes to build times. This does not have necessarily to do with architecture. However, in the past, module federation, which is a very famous tool for implementing micro frontends, have been coupled to Webpack. And now the big question is, how can we use the ideas of module federation without Webpack? Now, as Webpack is not the default anymore, how can we bridge over to the world of ESBuild? And for this, we have implemented something we are calling native federation. Perhaps we can talk a bit more about this a bit later.
How does Ngrx help with modularization?
Yeah, the good thing about Ngrx is there is one feature. It's basically a linting rule. And this linting rule allows you to categorize all your libraries. That means you subdivide your libraries or your application into several libraries, and then you tag them. You say, well, this is a feature of the domain booking, and this is a feature of the domain boarding. And then with those linting rules, you can enforce boundaries. You can say, well, a feature from booking is not allowed to directly interact with a feature within boarding. And this makes sure that you have decoupled contexts in terms of domain-driven design, decoupled modules. This makes sure that one module is not bleeding into other modules. And this is vital when we talk about an enterprise-scale application. I think not only when we talk about enterprise-scale applications, but especially there. I think we all know the situation where we have to maintain something here and break something there. And this can be avoided if we can enforce those boundaries. And this is especially important if we have a system several teams work on, because you don't want to break another team's work when modifying your own code. And so also we need, as mentioned before, good fences here.
Isn't the sheriff doing the same? Can they be used together?
Yeah, it's not exactly doing the same. It is just implementing the module boundaries in a different way, saying this Ngrx brings a lot of other features. And that's why usually we use both together. With Ngrx, you also have incremental compilation. That means you only need to recompile an application you changed. We have incremental testing, which means you only need to retest stuff you have changed. We have the build cache. That means if a colleague already compiled something or tested something, and if we did not change it, we get the results immediately. We don't need to do it again. And we have the Ngrx cloud that is doing everything in parallel. Ngrx is analyzing your source code, your structure, and so Ngrx knows what needs to happen in sequence and what can be done in parallel. And because this is dynamic, Ngrx finds out about changes and adapts to it. This is one of the drawbacks if you would do it by hand. If you would hard code this into your CI/CD process by saying, first of all, do this and then do that. If the dependencies change, then perhaps we need another strategy of building all of this, another sequence, and perhaps we have other rules for doing stuff in parallel. So this is what Ngrx brings to the table in addition to module boundaries. And of course, Ngrx also gives us several integration into tools for free. We get a storybook integration for free. It's just one command and pops your uncle. We get a playwright integration for free. We get a Cypress integration for free. Stuff you don't want to set up by hand. One thing Sheriff is also doing is setting up module boundaries, but not on a per library basis, but a bit more fine-grained on a per folder basis. So it's a bit more lightweight. You don't have to implement that many libraries. You can just define folders, you categorize those folders, and then you can define rules. For instance, this folder is not allowed to access that folder.
Does modularization with folders prevent using some Ngrx features?
Yeah, totally. This is kind of a trade-off situation. We also discussed this quite a lot in our workshops and in doing consultancy. For me, software architecture is mainly about trade-offs, and you have to evaluate all your options and trade-offs for a given application. Of course, if you go with Sheriff, with a per folder structure, it's more lightweight. However, you cannot recompile on a per library basis anymore. Perhaps everything is in there in one application or one library subdivided into folders. Preventing a compilation on a per library basis is not that bad, because Ngrx works the best when we have several applications. Most of the effort goes into compiling an application. And if you change a library, you also have to recompile the underlying applications. This is the case because when we compile an application, we have all those heavy optimizations like tree shaking, for instance, or other stuff we want to squeeze out of our bundles. And so this is a lot of effort, and that's why in general we need to go with several applications in Ngrx to speed up the compilation. There are, of course, exceptions to this rule, but as a rule of thumb, I would say it's like that. However, if we talk about incremental testing, also incremental linting, it's completely different. Ngrx is really good at executing unit tests, end-to-end tests, and the linter for a given library. And in this case, you can tell Ngrx just retest, rebuild, or relint the changed libraries. And this speeds up everything tremendously, as we can think. So this is something you would lose for sure if you go with a per folder structure. And so one more time, as mentioned, it's a trade-off between having a more lightweight structure and having all those great features that speed up your build. And this is, as mentioned, what I really want to tell people in our workshop. It's never a one-size-fits-all solution. It's more about downloading several flavors, several patterns into the back of your brain and applying them when they make sense.
You're listening, Angular Master Podcast. Listen, code, repeat. Everything you need to know to become an Angular super developer.
Let's talk about the Ngrx signal store. Why do we need another store?
Yeah, that's a good question. So I think one team member once made a joke. They said, well, we are quite good at implementing stores, and that's why we have implemented a third one. But I think this was a joke, because in general, it's about getting a more lightweight solution. This really fits to the Angular renaissance and to what I told you before about finding the sweet spots between over and under engineering. And it is also highly extensible. That means you can write your own extension to cover cases you need time and again. You can really centralize logic for, let's say, CRUD use cases, undo, redo, and other stuff in one place, and then reuse it when needed. With just a few lines of code, you can implement this or that logic for another entity, for instance. So it's really highly extensible. And this extensibility is baked into the design of the signal store. It really has a clever design. It is using the TypeScript type system from the beginning, and this allows us to be type safe on all different locations in the source code. Even in locations, we would not even think that this could be type safe, like introducing a dynamic property. But if you tell the TypeScript type system about this dynamic property, it can enforce the proper usage of it. Another thing the signal store is great at is, as the name already tells us, it's signal-based. There is no direct dependency to RxJS. But if you need RxJS, there is an interop layer. This allows you to use RxJS and all the goodness of RxJS, all those great operators you very likely don't want to write by hand in your signal store when needed. But if you don't need it, then you don't have a dependency to it, and then you just go with signals. This is also the plan of the Angular team. They told us they want to make RxJS optional, which does not mean that you should not use RxJS. It just means you get started without it. But if you need it, and all those operators that really gets a lot of pain away from you, then you can add it to the game. This is also the case in other communities, like in React or Svelte and so on. You don't get started with it, but you add it when you need it. And last thing, why the signal store is a good idea or might be a good idea for you, it's not Redux based, which makes it one more time more lightweight.
Isn't Redux a thing anymore?
Well, that's actually a good question. I would say it's still a thing, and we should still know about it. It provides a lot of meaningful aspects. One aspect is it forces us into a clear structure. Redux is opinionated, and it tells you how to implement your application. And sometimes it even forces you to implement the application in a given way. And this is vital when we think about a huge system, because there you want to have a uniform way of doing things. If you have 5 people on the team, they should work in a similar way. They don't should come up with their own patterns and implement everything differently. And this is even more important if we have several teams working on one system. So having a clear opinionated structure is one of the benefits. Another benefit is Redux gives us a lot of indirections. Think about actions and effects. This allows us to decouple parts of the system, and it is beneficial for testing. So it provides a lot of benefits, and that's why we should still have it in the back of our head. However, if you sit down, if you land back, and if you think about your system, and if you find out, well, I don't need all this goodness of Redux, then you might prefer a more lightweight solution. And then you should really look into lightweight stores like the Ngrx signal store. And this brings me back to what I said before. Software architecture is never one size fits all. It's always about evaluating possibilities in the light of your current application. That's why we should know about all those possibilities as architects. Funnily, we have the same situation in other communities. For instance, if we think about SolidJS, SolidJS comes with a little tiny lightweight store. It is doing some magic in the background, but the API surface is really lightweight. And if this fits, people go with it. If this does not fit, people download something that is doing Redux for them. So yeah, perhaps Angular is becoming like other frameworks in several senses, where we start without a lot of ceremony, but where we can add it when needed. And perhaps one last thing, we talked about the extensibility of the signal store before. It is totally possible to implement Redux on top of the signal store using this extensibility mechanism, using custom features, as they call it. 2 colleagues of mine, Rainer Hanekamp and Michael Eckert-Sickes, did this. We launched a library called Ngrx Toolkit before Christmas. It was our Christmas present to the community, and it implements Redux on top of the signal store in a very nice way, if you ask.
What this extensibility mechanism in Signal Store about?
So if we look into the Signal Store, there are a few fundamental building blocks everything is built with. You can introduce state in the form of signals. You can introduce computed signals, which is what you could call your view model, the state adopted to a given view. It's also what we used to do with selectors before. It contains methods operating on the state, and it contains hooks in the sense of lifecycle hooks. There is an onInit hook that is executed when the store comes to life. You can use it to load some initial data into the store. And there is an onDestroy hook you can use for cleaning up your stuff before the store is thrown away. And with those 4 building blocks, you can implement almost everything in the store. And now let's imagine we have implemented one feature that is doing one specific thing with those 4 building blocks. In the case of the extensibility mechanism, we could just grab those features with those building blocks and put them into a custom feature. And that means we have just one method or one function, to be more precise, that sets up this feature for a given use case. And if we go a step further, we make this function, this custom feature, delegating to signals, computed signals, methods, and lifecycle hooks, generic. Generic in terms of TypeScript generics, type parameters, and so on. And this allows us to use this one feature, this one function, for a huge range of similar use cases. One example I have, and it's also part of this Ngrx toolkit I told you before, is a data service for implementing CRUD operations. It allows you to set up a store for CRUD operations, including undo-redo logic in under 10 lines of code. It's really ridiculous, just 10 lines of code, I think a bit less, and you have a store doing everything you need for managing this very entity, for calling a data service, talking with the backend, and for doing undo-redo. It even allows to select several entities and to define one current entity that might be edited or deleted or something like this. Under 10 lines of code. I think this is one of the, or a nice example for this extensibility mechanism.
Where in the architecture does such a lightweight store live?
Yeah, that's a great question, because this is a question that is easy to answer for the traditional Redux-based store, and it's not that easy to answer for a lightweight store. At least when it comes to the lightweight store, there are more answers, more possibilities. When we talk about Redux, it is quite clear. In Redux, we define feature slices, or in the Redux-based Ngrx store, we define feature slices, and they are associated with one feature of your application. And the people behind Ngrx also suggested that we could pull down those feature slices to the domain level, because it's very likely that several features belonging together, several features of one domain needs the same state. So in this case, it's quite clear. We do it on a feature level or one level below if several features need to access the same state. However, if we talk about a lightweight store like the Ngrx Signal Store, we have several answers. Such a store could live everywhere in your application. You could implement it on a feature component level for a smart component. Then it is really connected to this component, provided by this component, and that means the store lives and dies with this component. This is also what we did with the component store. It provides a mean to define local state. We can do it on a feature level. Quite often, a feature consists of several components. For instance, think about a wizard we need to step through. And in this case, we can define a store with all the data for this wizard on this feature level. And finally, we could even define the store, the lightweight signal store, on the level of an UI component, of a dump component, which sounds a bit ridiculous at first place, because normally we always say a dump component should not have access to the store. And yes, that's totally true. It should not have access to the store with application data, because application data is not the business of a dump component. The dump component should work universally. It should be able to reuse it. That's why it should never access application data. But it turns out that even a dump component can have a lot of state. Think about a scheduler component. It has a lot of state. And so we could also define a signal store on this level to manage the state of this very dump component. But this state is not exposed, and we are not grabbing out to the application state. This is also a use case we used the component store before. And this is also a use case why the component store was originally implemented. Of course, we can implement a signal store on the domain level, because as mentioned before, it's very likely that several features of the same domain need to access the same data or the same state. So if this is the case, then we can pull it down to the domain level. And sometimes we even might to use a signal store on the utility level. A lot of utilities are stateless. Think about calculating dates and times or formatting dates and times. So such a utility is stateless. But if you think about authentication, we could have some state in there. We need to know about the current user, and we need to know about some properties of them. And so having state there is totally negative. So it can be on every level. And I think it would be good to start locally and to pull it down to a more global level when needed. And another question is here, does a layer of our application expose those stores? And the answer is it depends. Some of the stores are exposed by a layer. For instance, if we talk about a store on the domain level, we need to expose it because several features need to access this store. If we talk about a feature on utility level, authentication, we also need to expose it because features want to know who the current user is. But if we talk about the feature level, store on a feature level or store on the UI level, normally we don't expose those stores because in those cases, those stores are an implementation detail of this very feature, of this very dump or smart component. And yeah, so we don't expose it. The caller should not even know that we are using a store in this case.
One of the benefits of Redux was that it prevented cycles. How do we prevent cycles when we're going with lightweight stores?
Yeah, so we do it in a more traditional way. With Redux, we have a lot of rules and interactions. With the lightweight store, we can go with a more traditional way. We can use layering, something that is enforced by Sheriff and or Ngrx. We could say, well, a feature is only allowed to access, let's say, dump components or data structures or utilities, but a feature is not allowed to access other features. They are on the same level. Or we could say domain logic is not allowed to directly access a feature, or a utility is not directly allowed to access a feature or even a dump component. And by having this layering, we can enforce some means of decoupling, and this also makes sure we don't have that much cycles in place. So this for sure will reduce the possibilities of cycles. And another rule I really like to enforce is one store should not access other stores. I think if stores begin talking to each other, we end up with a mess, because then they try to synchronize each other, and then we end up with cycles, inconsistencies, redundancies, and we don't want to have something like this. Sometimes you might need several stores because they are on different levels and they are lightweight and tiny, so it's quite usual that for a bigger use case, you need to talk to several stores, but I would abstract this with a use case specific service. The service that takes care of one given use case. It can then orchestrate your stores and give you what you need, perhaps the current user and some data we have loaded for this current user.
What with preventing redundancies and inconsistencies in lightweight stores?
Yeah, so when it comes to redundancies and inconsistencies, then in theory, we also have this issue with Redux-based stores. Because in Redux-based stores, we think in terms of feature slices. And so no one prevents us to have the same data in different feature slices. Sometimes we do this by accident, and sometimes we really want to do it, because it might be the case that a product here is something differently than a product there, and it should not be synchronized. But the good thing about Redux is we have everything connected to one tree. And this tree can be visualized by DevTools. And in theory, we can do the same with the signal store. We can also implement some support for DevTools that gives us a look into the whole state so that we can find out, hey, there is a redundancy or an inconsistency. And it can connect the signal store to the traditional Redux DevTools. We have also implemented this with our Ngrx toolkit. The Ngrx team won't do it. They have no plans for it, but they have a good reason for it, because chances are high the Angular team will implement something similar for signals into the Angular DevTools. They want to visualize your signals and the graph that connects all the signals. And if we have a feature like this, we can also easily visualize the contents of a signal store. But this is more or less music of the future.
Last year, the Angular team introduced hydration and deferred loading. Should every Angular application use it?
Well, I would say no. If we have a public-facing application, yes, then this makes a lot of sense. And then also the additional effort we get when doing SSR makes sense, because if we are talking about a public application, page load is king, and also SSR is king because it allows us to optimize for search engines. So in this case, it makes a lot of sense. But if you don't have a demand for all of this, then I would leave it away, because it makes your application more lightweight. One less thing to think about, one less thing to fix when something goes wrong. And finally, when we look into the current Angular survey, it was published, I think, last week, then a lot of people say they are not interested into SSR. And a lot of people said initial page load is not their biggest issue. Runtime performance is a bigger issue than the initial page load for them, according to this survey. And I think this is because a lot of people use Angular for enterprise scale applications, for business scale applications. And I can tell you out of my practice, yeah, that's right. In those cases, it's not the biggest issue. We have other issues to deal with. However, as mentioned before, once we go public facing, this changes dramatically, because then we need all this stuff. And that's why I'm really happy we have great out-of-the-box solutions for all of this in Angular meanwhile. And more generally speaking, we need all those features to be competitive, because even though it's not a big topic, if someone decides for a framework and if they say, well, Angular is not covering this topic, perhaps they won't decide for something else because they might need it in the future, or they think they might need it. So it's really good we have these features, and it's really good that Angular adopted to all these new ideas that come from little tiny fresh frameworks. Angular absorbed those ideas, and this also shows that the Angular ecosystem is healthy, that Angular is adopted and renovated from the inside. So it's a good message to the community, if you ask me. Deferred loading, by the way, is very unobtrusive. compared to SSR and hydration, deferred loading does not bring a lot of burden. It's a drop-in solution. You just activate it. It's a turnkey solution. You just activate it. And so I think it can be also useful for business applications. Perhaps if you find out, well, we have a runtime issue here or there. As mentioned before, according to this survey, runtime performance is more important to the community as startup performance. However, this discussion one more time brings us back to something I already mentioned before. I mentioned quite a bit in the beginning that we need to have sound modules with sound boundaries. And if we find out when defining those boundaries that we have one customer-facing part of our system and a private internal part, then of course we would activate all those features for the customer-facing part, but not for the private part. Another example, by thinking about the bounded context, as it is called in domain-driven design, in strategic design, makes a lot of sense.
Where do you see micro frontends in 2024?
I think here the situation did not change a lot. If you have the situation that you really need to decouple your parts of the system, your bounded contexts, this is also where I come back to this theory of bounded contexts. If you really decouple it in terms of having different teams, perhaps even around the globe, working on them, then micro frontends are very, very tempting. Because in this case, each and every group can do their stuff, and then they deploy it when they are done, and suddenly this stuff becomes a part of the overreaching system. So it's really a nice idea that also comes with a lot of consequences. And because not all of those consequences are great, some of them are drawbacks, some of them are benefits, one more time, we should evaluate if this makes sense in your case. If you can work together with other teams in a monorepo, and if deploying everything together is not an issue for you because those teams work that nicely together, then this is for sure a better solution. Because Angular is thought that way, that everything is compiled together. This is part of the DNA of Angular and all the other single-page application frameworks of the current generation. This might change a bit. For instance, Vite will introduce first-class federation support. So this might change a bit. And it's for sure a huge deal if you have the situation of those large-scale applications where a lot of teams work on it. It also helps with migrating your stuff because you can migrate little by little from one technology to another technology, or perhaps you only write the new applications with newer technologies. I think we all remember that migrating from AngularJS to Angular was not that nice, and Ng Upgrade did an awesome job, but sometimes it was easier to just re-implement one part, one vertical, one context, one subdomain of your application with Angular while leaving the rest in AngularJS. And this is also the idea of going with migrations and micro frontends. But first and foremost, it's about teams that need to work in an autonomous way. And we find such situations a lot in banks and insurances, where really huge applications are built by different specialized teams. One team might be specialized into this kind of insurance, and another team might be specialized into another team, into another kind of insurance. Or when we talk about banking, one team might be specialized into loans, and another team might be specialized into accounting or perhaps into stocks. And so they can do their stuff and bring it together at once. So I don't think this changes a lot with 2024. We have benefits and drawbacks. We need to evaluate it. Funnily, all of this nicely fits to what I told you about modules and the bounded context. But one thing is changing. and this is influencing how we do micro frontends with Angular. Namely, I've mentioned it in the beginning, with Angular 17, we get ESBuild by default. And currently, there is no official module federation implementation for ESBuild. And this gave me to think. I thought about it, well, I don't want to implement a solution for ESBuild and then for the next bundler and then for the bundler that comes after that bundler and so on. I want to have one solution that works with all the bundlers out there, with all the frameworks out there. And it would be nice if it would work with web standards so that it is meaningful in the long term. And that's why what we did is we implemented native federation, which is a browser-native approach towards module federation. It looks a lot like module federation. We have the same configuration files, for instance, and we have the same API. But underneath the covers, we are using web standards like ECMAScript modules and import maps. And we have loosely coupled it to the bundler. Our current implementation is using the ESBuild bundler, the ESBuild builder, the Angular team comes with, but we could totally exchange it for other bundlers. And so I think it's really future-proof, and we don't have this burden anymore when we get the next bundler or the bundler next of the next bundler and so on and so forth. Perhaps one interesting thing with the next release of native federation, we are using even more features of Angular or the Angular CLI. So the idea is to implement as little as possible and to reuse as much as possible from the Angular team, from the Angular CLI, because we have limited resources and we want to benefit from everything the Angular CLI team is doing, and they are really doing a lot. With each and every Angular CLI version, we get smaller bundles and faster builds, and we just want to leverage this and just add a little tiny logic on the top that is doing the federation stuff.
Angular feature you are waiting for in 2024?
Yeah, good question. So I'm really eager to get my hands dirty with the new Signal APIs. I mean, we already have signals in there, but this is just the beginning. Quite soonish, we will get Signal inputs and outputs. First of all, we get inputs. I think a bit later we get outputs so that the API is uniform. And this allows us to talk with child components in a Signal way. And then we will get further features like Signal components that allow us to write everything on top of signals and to completely get rid of Zone.js. I really think this is exciting. It makes our developer experience more streamlined because we don't have this expression was changed after it was checked issue anymore. And it also works without Zone.js. I think Zone.js is not the most popular part of Angular, and I think giving us the perspective to get rid of it, or at least to make it optional. They will support it because they are very careful when it comes to not breaking stuff, but making it optional will be a good thing, I guess.
Manfred, thank you very much for today's recording. It's always a great pleasure.
I thank you. It's always an honor to speak with you and to be a guest on your podcast.
Thank you so much, and see you soon.
See you soon. Bye-bye.